Hello, and now a video where I open my post. Now, what shall I call this? Postbag. Let's start with this one, using scissors today. Why not? Oh, they're not as convenient as a knife, are they? And I've probably cut something up. Oh, lots of wires. So, lots of red wires and one black wire. And this thing in a bag. And it is one of these lithium-ion cell active balancers. And this is the latest incarnation. And they have a touch switch. So what do we have on here? Well, the usual array of capacitors, MOSFETs, more capacitors, more MOSFETs, more capacitors. A couple of controller chips. There are two here. Presumably they do 2 channels each. The touch plate goes to this little 6-pin device here. That then drives this little 3-pin SOT23 device. And there are a couple of points here which you could put a jumper in, I presume, that essentially shorts out 2 pins of this device. So is this a touch switch override, which I think is important because you don't want this to only work when you touch it. You want it to, well, I want it to work all the time, like the one on my battery in the shed. Must do a shed update soon. Now there's another pair of pins here, which again could take a jumper. I've no idea what that is for at the moment. Now, can I actually power this up, or should I leave that for another video? Maybe I'll look at some chip numbers. Okay, the MOSFETs are SM4377, and those are 30 volt 50 amp N-channel MOSFETs. So yes, those 16 items are all MOSFETs. The touch chip is a 22021D, and if I put 22021D with touch into Google, I don't get anything from that, but it's going to be similar to the TTP 223, I think it is, touch switch chip. That MOSFET next to it, or device next to it, I think is a MOSFET. I can't get a reflection off there. Right, this is an A2SHB, I believe that's an N-channel MOSFET. This says C14. The only thing I can find in a C14 SOT23 5-pin is a single gate Schmitt trigger. I'm not sure whether I've got that right, but I suppose it's possible that's a Schmitt trigger. And these two chips are EG2104M, which is a MOSFET gate driver IC, and there's a datasheet for that on LCSC. So this is the item on AliExpress, and it's a 4S, 4 cells in series, 5 amp lithium battery active balance board, capacitive, 3.2 volts, 3.7 volts. So it's good for lithium ion and lithium ion phosphate. So it's an active balance board. Now, interestingly, this one, the photograph, doesn't show the little 2-pin link that shorts out the A2SHB MOSFET. So maybe that was added later, people saying, I'd like a way that I could have this thing on permanently. I assume that's what it's for. I don't know yet. $8.98 free shipping this one was from Daddy Store. And there's not much information on it here other than what the accuracy is and the equalizing current. Now 5 amps will be the absolute maximum. Of course, once it starts to balance, that current will drop fairly rapidly. And photos here, but again, that 2-pin link is not on this version of the board, and the word touch is in a slightly different place. Yes, that's about all they tell you. So what I'll probably do with this is take off the rear 4 blocks of 4, these modules as I called them in my Vroo's End video, and build a 4S pack with those, and then get this active balancer on there just to see it working. But I think that's beyond the scope of this video. I think we need to move on to the next postbag item. which is this. Back to yellow envelopes, and perhaps I'll use the blade for this one. I don't think there's anything up at this end. And in here we have this device, which is one of these, well, you're probably thinking voltmeter. This one's actually an ammeter. Actually, no, you're probably thinking ammeter because you've got the high current cable in here as well as the low current cable. What's that red thing? Oh, that's the stripe at the top of the bag. And this one, I think, is 5-digit. Let's get this bag open. And it also, yes, it is 5-digit. So I think it's fairly accurate. And it also, I think, as far as I remember, measures negative currents as well as positive currents. So it's bi-directional. Let's have a look at the PCB. And there's a Nuvoton chip there. Another chip up here, which I can't see the markings on. So I'm guessing the one in the middle there, let's get a pointer, is the microcontroller. This one up here is possibly a display driver of some sort. The big, well, copper, it might be a different metal, current shunt with a couple of markings in it where it's been slightly compressed to change its resistance. Although actually that's not necessary because there's an adjustment pot on this one. That's almost certainly a regulator. I think I can see a 3.3 on it, so it's probably 3.3 volt. I can't remember what the input is. Oh, 4 to 28. That's quite a wide range. And it goes up to 5 amps, which is good. Okay, let's put a battery on this and get it fired up. I'll just shove this 9-volt battery on it just to see if I can get it to light up. Yep, it's upside down, so I'll turn it that way up. Let's put that back on there. And yeah, so we've got 0.000, so 3 decimal places, so that would be milliamps, wouldn't it? How can I do this slightly more permanently? I've got this, let's try that. 12 volts on here from the lead acid batteries outside. They're getting a bit ancient now. What's that? 11 volts. What was this again? Oh, 4 to 28. Yeah, that should be fine. So if I put that in this 2-pin plug and plug it in there, that should power this up. Now I was wondering if I can bodge some current through this thing from my multimeter. Perhaps in diode mode it'll put out a small current. Hopefully we can measure that on here. Let's get the light on there. I'll just connect these into these banana plugs. No, that hasn't worked. Let's try something else. How much current will one of these batteries produce? 5 amps? I think it's unlikely, isn't it? Okay, let's just shove that on there and see what happens. You'll want to see the display, won't you? I'll try and arrange that first. Okay, current test with a battery. This could put out quite a bit of current, actually. Oh yeah, that's interesting. It was a lot of current and then it fell down rapidly. But that's probably because this can't sustain 5 amps for very long. So that wasn't a very good test. How about this solar panel, which I found? I think it's probably 6 volt or something like that. So I've hooked it up to a couple of just connectors I had lying around. And now I've got this big torch. Let's see what that does. Okay, yeah, so I'm able to produce... well, it was far more than that, wasn't it? And now it's dropped a bit. I thought I saw 30 milliamps initially. But anyway, we're creating some milliamps. Now the question is, if I swap these two connections round, will this show a negative current? And yeah, I can also already see that it's minus 3 milliamps. Let's put the big torch on it. And that's gone to minus 20 milliamps. So yes, that works. That is a bi-directional ammeter rated up to 5 amps, which will be ideal for use with this, because when this is doing cell balancing, I want to be able to see the currents. Now, if it's balancing between cells which are high and low like that, and then another time they're high and low like that, the current in these red wires, and the black wire of course, could potentially flip to the other polarity, and we could get positive and negative numbers. So I wanted to buy several of these, put one on each of these 5 lines, which is going to be a bit fiddly from a wiring up point of view. But that's the purpose of this. Okay, let's go to AliExpress and look at this ammeter. This is the item on AliExpress. It is a BY436AF 0.36 inch digit 4-bit, and there are various different colours. Firstly, I obviously got red, 5 amps, 10 amps, 2 amps, 3 amps, 1 amp, 100 milliamps. And then these ones that say only meter, you have to add a current shunt. So you don't have to add a current shunt up to 10 amps, but you do beyond that. And voltage is 3.8 to 30. It didn't actually say that, did it? It said no, 4 to 28. Okay, that's near enough. $4.62. Shipping is $1.91 US dollars. These are from Gwanwa official store, and they have a 99.6% rating. Incidentally, if you're liking this video, then now would be a good time to
press the like button, why don't you?
Yes. Okay, moving on to the next item. And it's this. I did take the top off this bag, but I haven't actually emptied the contents yet. So let's do that. And it's these things, and they're just loose in here. No additional packaging. Let's take a look. So these are little boost converters. So you put, well, I can't remember the voltage range, but something on the input here. Now, in my case, it's going to be, well, as little as 3 volts, because I want to hook this directly up to a lithium cell. And then it will boost to a higher voltage based on this truth table. So you can have 5 volts, 8 volts, 9 volts, or 12 volts, depending on how you link these. Oops, these boards are coming apart. Depending on how you link these A and B pads here. So if you join them both together, A and B, that's the join symbol. It's not very clear, is it? That's not very clear at all, but I think I saw it on the... Can you actually see a little line linking those? Anyway, link them both together and you get 12 volts on the output. So we'll go straight to the AliExpress listing because I want to see what the input voltage range is for these. So these are the items on AliExpress. 10 pieces of newest multifunction boost module step up, 5 volt, 8 volt, 9 volt, 12 volt, 1.5 amp. Oh, I don't think, let's just switch to this. I found AL142. Oh, that says 2.5 amps, if that's the right item. I was just briefly looking for the chip, which is an AL142. But anyway, back to this. It says here in the description, input voltage is 2.5. So that's good for lithium iron phosphate, I think, at about the minimum voltage you take it to, 2.5 to whatever V out is. Fixed output voltage of 12 volts. Maybe that's when they're both unlinked, because you can also set it to 5, 8, or 9. Does it give the current? Oh, it does. 1 amp at 5 volts, half, 0.45, 0.3 at 12 volts. But anyway, it's enough to power this little ammeter. So this, it was 4 to 28 volts, wasn't it, for powering it? So 12 volts from one of these boost converters will be just fine, and I can derive that power from an individual cell, including lithium iron phosphate, down to 2.5 volts. It will still boost up to 12 volts to keep this meter running, so that I can watch the currents. And of course, I do also want to get some voltmeters similar to this, so I can watch the voltages, the currents in my lithium iron phosphate battery pack. Well, I didn't actually finish this, did I? Because these were $1.57 for 10 with $1.37 shipping. That's quite cheap, isn't it? And these came from Simple Robot Store, and they have 97.6% positive feedback. And so these are today's Postbag items. Now, big thanks to my Patreon patrons. They get to see my videos typically a day before anyone else does. And also it's before I switch on the advertising. So if you'd like to become a Patreon patron, oh, I could do an overlay here, couldn't I? Press that button there. More videos for you to watch here, and subscribe to the channel if not already subscribed. Cheerio.